Hello again, my name is still Jeroen van Bemmel and this is the third part of an application demo showing Nuage VSP version 3.2. In the first part we went over the process of deploying an application in an easy and automated way, and I'm going to repeat some of that quickly just to recap. But in this demo I'm going to focus on the elastic and seamless scaling of web applications to add more capacity, more resources to a given application. So again, first step in deployment, we start with an empty VSD, empty OpenStack, and I'm going to create a network for this new application. And run my make network script. And this is using the standard VSD API to create all the networks and subnets and security policies that are required for this application. It also imports these subnets into OpenStack such that I can use OpenStack to launch VMs and attach them to these subnets. So here we have the domain instance that was created. And if I look in OpenStack, I have my front, my back, and my subnet for AAA servers. First thing I need to do before I forget, I have to link this application domain to the shared domain where I have a private Docker repository running on a host somewhere in our data center. And the VMs I'm going to launch are going to run Docker images that are sourced from this private repository. By linking the domain, I make this shared resource accessible from this domain. So now any VM that is launched here can reach the Docker repository, and the security policies in the system allow this to happen. To start my first front end, I can pick any availability zone. Default security group, in this deployment model, the security groups are not used. The security policies are purely defined inside VSD, and security is controlled by how I place my VMs, so to which networks I attach them. Front end, back end, and I'm going to pick an installation script that initializes this generic Docker VM as a ecCloud front end. The script mainly launches the right image from the public repository for the private repository. OpenStack picked an IP address for each VNIC. This VM has 2 VNICs. And if I go look at the console just to show what's happening, it's downloading the image from the local Docker repository. It goes fairly quickly. Just check in OpenStack. If I expand my view, there's my VM. It has 2 VNICs, one attached to the front and one attached to the back. And it's up. If I look at the front-end interface, there's a static route pointing to a virtual IP.10 and with the next hop of .1, which is the real IP address of this VM. And this front-end VM is attached to a shared zone. And if I look in shared zone here, shared network, shared subnet, this is attached to a 7750 in our lab. So I can go to the virtual IP address.10, and this takes me to the real IP address.1, which is the first front end. Now, in order to scale this application, I'm going to launch additional front end VMs, and I'm going to run or use a public call generator tool called zip-p in order to simulate traffic. So client voice calls. This is the server side. It registers with the front end that I just started. This is the client side, and this client is going to start sending invites, 1 call per second, and it waits for 30 seconds and then it hangs up. Only the SIP signaling part is going through the application, and the media would be going directly between browsers. But just to show what's happening, this is a TCP dump on the front end, so here you can see the signaling currently going through this single front end VM. Okay, I'm going to leave that open. Now I'm going to start a second front end VM. Same thing as before. Front end 2. I'm going to let the system OpenStack pick a zone. It should pick the other server normally. Front, back. Obviously what I'm doing here by hand would normally be automated in some kind of cloud management system. It's the same thing every time, so I just have to pick the right parameters. C4H5 is the first one, C4H4 is the second one, so they're on different servers, and this one gets .2. Now, I did not create the route to the second one yet, because I have to wait until that front end is ready to receive traffic. It's pulling down its Docker image just like the first one. I could optimize this by making a snapshot of the first VM, such that we don't have to go through this process every time. But like this, it's nice to see what's happened. It's very flexible, and it just pulls down the image that I choose. And if I run TCP dump here, right now there's no traffic, no calls coming in. But if I add a static route to the virtual IP address of .10, but with the next hop IP of .2, which is the new VM, that second route resolves to this second VM. So now, if we go look at the VM, we should see the occasional call coming this way. So what's happening is the 7750, the PE router, is distributing the traffic between these two VMs, because it has two routes for the same IP address. It will randomly pick one of the two and forward messages to that whichever VM is selected. So now both VMs are processing calls, and if I look here, the client didn't notice anything. It's sending its messages to whatever IP address it receives. It initially sends the message to the .10 address, but it receives back the real IP address to continue the call. So now I've scaled the application from 1 to 2 VMs, and in the process I've added also redundancy. So now I have 2 redundant VMs on 2 different servers. If one of them fails, the other one should be able to continue. So this is scale up. The complementary part of that is to scale down. And that's basically, it's very simple. It's the reverse of the scale up. So first thing I have to do, let's assume, for example, this second front that needs to be updated. There's a new version. So what I would do is, I would first of all take it out of service. I'll go and delete this route, remove it. There, it's gone. The ongoing calls that were going to this VM will continue because they are targeted at the real IP address, not the virtual IP address. but there's no new calls being sent to this VM. So as soon as those ongoing calls are done, this VM is done. It doesn't receive any more calls. So now I can take it down. Shut it up. I could destroy it, launch a new one. And in the meantime, this client didn't notice anything. The calls keep on going. So in summary, what we've seen here is a example of how you can use Nuage 3.2 with its ECMP routing feature to seamlessly scale out and scale down, gracefully scale down a sample cloud application. All the things you've seen here are available on the public internet. Nuage is by definition open, so if you're interested in replaying some of this in your own lab, the easiest way is probably to use Docker, say docker run ecCloud setup, which will get a Docker-based version of this demo. But you can also create take the Ubuntu Cloud image and create a Docker, a VM hosting Docker containers, such that you can do this with OpenStack like I've shown in this video. Thank you for watching, and I hope you enjoyed it.